All right, good morning, pre-calculus people. So if you are following along and it's current, enjoy the lovely snow day we have in New Mexico. If you lived in Texas, that would be great because Texas got enough snow that they canceled virtual classes. So, that's it's good for them. New Mexico, however, did not cancel their virtual classes. So you will still have school at home in the snow. So yeah, I'm sorry. Snow days are now a thing of the past for a lot of us. And also, C&M had flooding last night. So if you were unceremoniously dumped out of your computer homework, whatever you were doing, I apologize for that. But they had some flooding. I'm not sure what the scenario was or what happened. All I got the message was, we're out for a while. Apparently they got it back up because I was able to log in and do some stuff. So, I didn't get a message saying that they were back up yet, but, so be it. There they are. Okay, with that out of the way, we are in the middle of logarithms, and I'm going to take this, again, kind of slow. We have a lot of time. I spent, last week I did some stuff to kind of clear this week for equations, which is good because this is a really important part of your education to be able to solve logarithmic equations, exponential equations. But, here we go. So let me start off with things I really like about your book. Because back in the day, okay, here's just the regular book for us. Back in the day, we had an entire chapter, entire section over problems like this. Okay, what we're doing here, okay, is just an example. We're not going to spend too much time on this, but I wanted to give you the idea of what's going on. It's to say 2 to the x is equal to 32. And the whole goal of this kind of problem is figure out how do I rate 32 in terms of powers of 2. So you can say, oh, wait a minute, this is 2 to the x is equal to 2 to the 5th. Okay, now here's the step, is we're going to now equate the exponents, okay? And then we'll get x is equal to 5. Okay, and they start being a little bit tricky with this stuff, okay? We'll start being a little bit better here. Like number 9 says 2 to the negative 3y plus 1. So we have 2 to the negative 3y plus 1 is equal to 16. Excuse me. And again, we'll keep this in case somebody comes in. What we're going to do is we're going to take this 16 and say this is 2 to the 3 plus 1 is equal to 2 to the 4th. Okay. And again, we're going to equate the exponents. That's the thing you're allowed to do, which is why base 1 can't be there, because we get 1 and every answer is now fine. We get ridiculous answers like 3 is equal to 4. But as long as my base isn't 1, we can equate the exponent, and we'll get 3y plus 1 is equal to 4. Now we could solve this little equation here, right? We could subtract 1 from each side and say negative 3y is equal to 3. Y is now, okay, so negative 3y is equal to 3, and then we'll get y is equal to negative 1. Okay, so just to kind of recap here a little bit, right? We have two equations. We have two sides of an equation. We're going to turn one of them into the base of the unknown. Okay, or what we're going to try to do is we're going to match the bases. Okay, that's what we're going to do, is match the bases, and we'll get 32 is equal to 2 to the 5th, and then we equate the exponents, and then we solve. Okay. Like I said, they can get a little bit harder, but the idea here is still we're going to equate, right? We're going to make the bases the same, and then we're going to equate the exponents, and then solve for the variable. There's an obvious question here, and that question is, what do you do if you can't make them the same base, right? Like, what if I do something like 2 to the x is equal to 3? Well, there is no way I can make 3, right, 2 to the some power. I mean, you can, but there's going to be a lot of guessing as to how this works. Okay. So there is a way to do that. And the way to do that is, do you remember we talked about logarithms? And we said that logarithms are an exponent. So what we're going to do is we're going to take the log of both sides. Okay, so we're going to take log of both. See, when I went to school, they had like an entire week of this kind of problem. Okay. You think, oh, that would be so nice. I'm like, no, after you've done 3, you're going to be bored to tears, and it's going to feel like filling out your tax returns to do this homework. It is terrible. All right. So here we go. We're going to take the log. 2 to the x equals the log of 3. I'm using base 10 here just because it's the easy button I have on my calculator. And then remember, there was a log rule that lets you take down the exponent and put it on the baseline. This was log rule 3. So this is going to be x times log 2 is equal to log 3. I forgot to put my calculator up today, so we're going to have to right now, this is not reducible really. Okay, I mean, there is one thing you can do with this, but it's really not important, and it's not going to help you with your calculator to do this. Okay, so on the calculator, I'm just going to type in, right, log parentheses. It'll open up the parentheses automatic, close parentheses. Important to do this. Okay, that's an important step. Divided by, so we're going to hit the divide button, and then log, that's another button, and it'll bring up 2, right? Close parentheses, and then hit equals, and let's see what we end up there. We end up with, and you can't see me doing this, I'm sorry I didn't do that, but it's going to take me a while to find it. So I have an emulator, but I have no idea where it is right now. And we get this mess, right? So right now, right, the answer, right, when they want you to write this down in the book, right, or they want the exact answer, there you go. That's the exact answer. Okay. Now, if you need to figure out what the number is here, because maybe it's for time or something like that, you're going to come up with the fact that x is equal to 1 point, okay? And then it's going to go on for a while because it's not a rational number, okay? 1.5, oops, here we go, 5, 8, okay? Nice if I had my light on. 496, so here we go, 496, that's probably, it keeps going, okay? But if I type in, right, 2 to the 1.58496, and if I had more time, then I could do that, and we could type in what that is. So we're going to say 2, right, caret, and then we're going to type in this number. And what's funny is like maybe type in 1.6 at first and see what you get. You're going to get a little bit over 3, and then type in 1.58 instead, and you'll get a little bit closer to 3, and then 1.5849, and you'll get closer. Okay, so we're just going to take 2 caret and then 1.4 or 1.58496, and look at this. I got like 2.999 all the way out for a while. Okay, so this is the exponent. 2 raised to this power is equal to 3. And I know just by looking at this, you would have guessed it, right? It was just been done by inspection, right? Sure, it would have. You know, but that's what we use logarithms for. It's like 2 raised to what power is equal to 3? 2 raised to this power. And that's why we take the logarithm of both sides to do that. So you have exponential functions is equal to some number. That's how you're going to solve them. All right. So let's jump to something a little bit harder. Okay. I think number 12 or number 13 is one of the ones in your, no, number 14 is the one in your book. But we'll start with number 13 and we'll maybe do 2. Okay. So we have, oh no, we don't want that one. That's too easy. Actually, all of these are too easy. What are they doing? They're not. This is the kind of thing we want. Yeah, I don't want to do this one because we can write 9 as a power of 3, 27 as a power of 3, right? We don't want to do that. We want the hard ones. Okay, sorry, but we do. So like 27, that's what we want, right? We want 3 to the 6x plus 5 is equal to 5 to the 2x. And again, like I can't guess, right? I mean, there's no way of writing 3 as some kind of a power of 5. We can't do that, okay? So what we're going to do is we're going to take a logarithm of both sides. It doesn't matter which logarithm you take, okay? If you like log, then go ahead and use log. If you like natural log, then go ahead and use natural log. If you want to flip every other problem, then you go right ahead and flip every other problem. It doesn't matter. So I'll use natural log this time and say this is natural log of 3 to the 6x plus 5 is equal to natural log of 5 to the 2x. Right? Take logs of both sides. Okay, then we're going to abuse rule 3 again. Okay, we're going to use log rule 3. By the way, I don't know like what this is technically called. And in every book, it's the third rule of logarithms that you see. So that's just why I memorized it as log rule 3. But here's the scary thing. I don't memorize names of rules ever. But this one I happen to memorize. So that should tell you how often you're going to use this. Okay, so we're going to get parentheses 6x plus 5 times natural log of 3 is equal to 2x natural log of 5. Okay. Now, if you want to type, okay, I would not recommend you do this, but if it helps you, especially at the beginning, to take and write log base 5 to convert it to a 4-decimal number. And by the way, you are always going to, well, I won't say always, you can do more, okay? But the standard is to type this thing out to 4 decimals. Why to 4 decimals? Because back in the day, before we had electronic calculator, this is before my time. I always had a calculator. I could hit the log button. Okay, but back in the day, there was a you had to look these things up in books. They were the CRC books. Okay, I know you can still find these occasionally at a garage sale or in an old library. But they had the CRC books, and they had. I mean, this was Google before there was Google. Okay, like you needed a molecular weight of something, you needed a melting point of aluminum or something. The CRC chemistry book was where you went. Okay, you needed the elasticity of a certain kind of steel. You went to the CRC book of physics, and in math you had the CRC books for the logarithms. Okay, and sines and cosines. Everything else. Okay, these giant books of tables that you had to go look up. Okay, so enjoy the fact you live in the 21st century. Okay, you have a phone that'll do it all for you. Your Google machine, right? If I said, hey, I really need the molecular structure of caffeine, like, bang, Wikipedia will have it right there. And I know my colleagues will get mad at me for suggesting you use Wikipedia, but for the most part, scientific stuff like that is people don't come by and vandalize it, right? Or if they do, they're usually terrible, and it's obvious. And somebody looking it up was like, "That's not right. Let me look at my book and see." So, trigonometric formulas, I use Wikipedia all the time for this because one, I can usually tell if somebody wrote a bunch of nonsense. Not always, but we're gonna. 1.5. Yeah, if you just type in, sorry, I didn't see that, 1.2 to the 1.5, right, you're going to get, what are you going to get? You're going to get, less than 3 to the 1.5. You get 2.828 and some stuff. The closer you get to this number here, the closer you're going to get to 3. That's all I'm trying to say with that, is that's you're just getting closer and closer and closer until you've gone all the way out. Right. So that's where that's about. Okay. But yeah, if you want to type this, and all the C or C books, they always went out to 4 decimal places. That's why, or at least the ones I did went to 3. That's what went to 4 decimal places. So, because we still have to learn how to use them. Okay, so that's what you're going to go with. All right. So if you have to type this out, you can go ahead and do that. And if it helps you, fine. I would prefer that someday you would do this like in the more grown-up way. But if it's helping you at the beginning, then it's okay for you to do that, because I'd rather you get comfortable with this idea than to be uncomfortable with it forever and think that this is some kind of mysterious thing. Okay, because it isn't. So what do we have here? We have 6 times the natural log of 3x plus 5 natural log of 3s plus 2, or equals 2 natural log of 5x. Right? Now the goal here is we want to collect all x terms on one side. Right? So what's going to happen here is we're going to have 6 ln 3x, okay, minus 2 ln 5x, and I'll put this on the other side. Okay, so it's going to be negative 5 ln 3. Do you need all the parentheses? Not really, but I'm trying to make it crystal clear as to what my intent is to say this is a coefficient, and here's my x, coefficient, and x. So it's real easy to follow. Okay, so later on, I may not write all the parentheses out, but if you do, nobody's going to tell you, like, why are you doing that? Because I want to make it clear, and then nobody's going to complain. All right, so notice there is an x common to both of these terms. That means we could factor out an x. Okay, so we could write down x, parentheses, no, I'll use those. 6 ln 3, all right, minus 2 ln 5. And that is equal to negative 5 ln 3. All right, and then we're just going to divide by this mess here. Okay, we're just going to take this whole mess. Okay, we're just going to take this whole mess here and divide by it. Okay, both sides. So we're just going to say 6 ln 3 minus 2 ln 5 equal to, oh, don't have to do an equal sign, it's just the bottom. At that point, we could say something clever like x is equal to negative 5 natural log of 3, all divided by 6 natural log of 3 minus 2 natural log of 5. All right? And that, if I put this back into, we could again generate about 4 decimals here. I wouldn't. This is why I want you to kind of get more used to using natural logs of numbers rather than trying to do 4 decimal places, because it's going to be a lot to carry around. But if you do, that's okay. At least for a little while, right? If you're doing this, maybe the first 10 problems you're doing the decimal places, and then the next 10 you start like moving away from them. That's probably a good transition. Okay. So if I went through and did this, oh dear, what do we have here? We have negative 5 ln 3, and then divided by, and I'll just do the whole divided by, so parentheses, we have 6 ln 3. Where's my ln again? There it is. Don't forget to close your parentheses, because otherwise you'll take the natural log of a bunch of stuff, and you don't want to do that. 2 ln 5, double parentheses, and it equals, and I got negative 1.6286. What do we have here? We have 682 we'll say 9. Okay, 4 decimal places, and it's thing there. Okay. But if I plug this back in, oh, it's a negative. Put this back in for my x, all the way back up here somewhere. All right, then that's what that would do. Okay. All right, lovely. Okay. And yes, I know this looks like a delightful answer, but that is actually the answer. That's what we're living with here. All right. So let's try number 29. Okay, I have 2 to the 1. I've used this one on a final exam before. Because this is a standard. I know I used 30 on a final exam. Number 2, I didn't use. Not yet, anyway. Okay. But if you can do 29, you can do 30. All right. The idea is that this is a pretty standard problem for exponents. So you should get some easy ones on your final, and this is one I considered an easy one. Okay. We're gonna take logs of both sides because we can't turn 2 into a 7 somehow. Okay, I don't know what exponent 2 raised to would be 7. Okay, so the idea here is we're going to take log of both sides. All right. So I use log. I'll go back and forth. Okay. So we have log of 2, 1 minus 6x is equal to log 7, 3x plus 4. Okay. So what we're doing here is we're really equating the exponents. Right? Because remember, the answer to a logarithm is an exponent. So we're just equating the exponents here. All right. Now we're going to use rule 3 to bring them down because I have to solve, right? If x is in the exponent position or variables in the exponent position, how do you bring it down? And the answer is we have to use logarithms. So we have 1 minus 6x times log 2 is equal to 3x plus 4 log 7. The reason you want to use parentheses on this is because I don't want to miss, right? I don't want to miss this and say, did I remember to say 3x times log 7? And did I remember to do 4 times log 7? So they both have to be visited by that logarithm. And if I don't use the parentheses, I'm likely to forget one of them. Probably this one. Okay, so let's go ahead. We have 1 times log 2, that's log 2, minus 6x times log 2 is equal to 3x log 7. Okay, and that is equal to, or plus 4 log 7. So there we are. So again, the idea here is we're going to collect all exponents, or all the x's on one side. Which side? It doesn't matter. It's up to you. Okay. Since if I add this one, it'll swing over to be a positive, I'm going to go ahead and add it. And we'll subtract 4 log 7 from both sides. Okay. So here we have a log 7 and a log 2. I can't add those, right? And it's like, well, I've got 3 euros and 6 yen. I'm like, great, how much is that? Well, without a bank, it's 3 euros and 6 yen. Okay. So here we have 3x log 7 plus 6x log 2. And this is equal to log 2, not log base 2, log 2. Okay. Log 2 minus 4 log 7. All right. And again, here we find ourselves in another position here, right? Where this x is common to both of those terms. We're going to factor that out. Okay, so we're going to have this is x times 3 log 7 plus 6 log 2, and that is equal to, we're just going to leave this alone. Okay, I mean, you could turn this into like 2 over 7 to the 4th power, but I don't think that's really worthwhile. I mean, this is a mess regardless of how you're going to put this. Okay, I'll show you what you can do, the magic you can do with this in a minute, but okay, now we're going to go ahead, we're going to divide both sides, right, by 3 log 7 plus 6 log 2. We have a 3 log 7 plus 6 log 2. All right, and when we're done, right, I'm going to turn it around, put the x side on the left, but we have x is equal to log 2 minus 4, we have a log 7 divided by 3 log 7 plus 6 log 2. Okay, so now, okay, don't do this, all right? Back in the day, before we had electronic textbooks, right, we had regular physical textbooks, and you'd look in the back of the book, and you would try to match your answer up. Here's a sneaky thing about people who write textbook answers, is that they are very, very bitter people. Okay, it's a tedious job, and it sucks. Okay, just to write out all the answers to the even or the odd problems, it's awful. And teachers, professors don't do that. That's why they have grad students. And yeah, that's what's going on there. So remember, we could take these logs. I can say this is log of 2 over 7 to the 4th divided by log of 7 cubed times 2 to the 6th. Then, okay, we're going to go ahead. We're going to figure out, like, what is 7 cubed and what is 2 to the 6th? 2 to the 6th is 64. So this is going to be log 64. 7 cubed was going to be 7 raised to the 3rd power here. Looks like 343. All right, so that's what this says. And then log of 743 times 64. So we're just going to write down 343 times 64. We're just going to do this arithmetic here. Okay, and I got log of 21,952. All right, that's on the bottom. On the top, we got log of 2 over log 7. I had one student that did this to me. He was pretty good, so it's possible. Okay, but for everybody else, I would say, please don't do this. Okay, so this is log of 2. 7 to the 4th was 2401. All right. And then you say, okay, well, I remember my change of base formula. So this is log base 21,952 of 2 over 2401. All right. And that used to be the answer in the back of the book for these problems, because, writing a whole bunch of answer manuals, eventually you start getting a little bit tired of writing them, and then you just decide, I'm going to take this out on everybody around me and not worry about the fact that it's technically correct, right? And nobody's coming by to check your work on, like, dozens and dozens and dozens of problems. They're just going to say, okay, you did it, that's good, we're done, and have a good day. So that's what's going to get published in your answer manual. Okay. And anybody working this problem is going to look at this and say, how did they get this? Okay, so you kind of have to be really good at doing this problem to know how they actually got this answer. Okay, but right up here, this one, If you do this, I'm going to be super happy with you. I think that's a great answer. All right, we should probably do a little bit in the book just to make sure that they think it's a good answer. I'm sure they will. I think this is what you're supposed to go to. They don't expect you to do this. But if you ever find a book that doesn't have a computerized system to it, don't be surprised. You're going to find stuff like this. Okay. All right. Let's see here. All right. I'm going to do these in a second. All right. So, yeah. Okay, so answers 35 and 36. All they want you to do is type these numbers in and see if you get the same thing. Okay. Obviously, B can't work because you can't take the logarithm of a negative number. All right. So, let's go ahead and take a look at this. How about we try this one, 37. So number 37, we have a log base 4. Now this is one case where the bases are actually important. So we have log base 4 of 3w plus 1 plus 11 rather. And that's equal to log base 4 of 3 minus w. Okay. Now, I have a lot of students who do this. All right, and the before times when I could see what you were doing, if you wrote this, then on like a 10-point problem, that's going to be a minus 11. Okay, that's not a good, you're not allowed to cancel the logs. Okay, I know that's about what it looks like we're going to do, but it isn't what we're doing. Okay, so I want you to be real careful in removing these. And there's 2 reasons. Well, there's not 2 reasons. There's another thing you have to watch out for a little bit later. We'll talk about both of those things. So what we have to do here is we have to make the logarithm the exponent. We're going to make 4 the base on both sides. Okay, why 4? Because that's log base 4. If this were log base 6, we'd make 6 the base on both sides. Okay. So if you just try to cancel the logs, a lot of times there isn't a log on the other side. It doesn't work, and people just cancel it anyway. You can't do that. All right, you have to. It's called, the proper term is saying, it's called take the anti-log. All right. I always say unlogify it, but that's not correct. Okay, that's not really English. So be careful when you're doing this. Make sure you've taken the anti-log correctly. Okay. Now it cancels because we know that the base, the log base of anything goes back to being that thing. So here we're going to have 3, I forgot a W, plus 11, and then it's equal to 3 minus W. Okay. Now that we've got the, now that we've got the 2 anythings equal to each other, we can just solve this like a linear equation. Okay, we're going to go ahead, we're going to add W to both sides. We're going to subtract 11 to both sides, and we're going to get 4W is equal to 3 minus 11, that's going to be negative 8. So W is equal to negative 2. But wait, you're not done yet. Okay. There used to be 2 equations that you'd have to check your answers for, right? One of them was a fraction, right? When you had a rational equation. Okay, you had to check your answer because one of the sneaky things to do would be give you guys an equation where the answer was like, x minus a, and the answer turns out to be a. Okay. So if the answer is a, that's not really a solution because you end up with a 0 in your denominator, and the whole equation is nonsense. Okay, can't happen. I would do this a lot to my intermediate algebra class, by the way. It's important to get some nihilism with your math. Okay. The other one, right, would be radical equations, right? Square roots, fourth roots, sixth roots, things like that. So if you ended up with the square root, right, and your answer happened to be negative, right, your whatever this turned out to be, right? How about we do it this way? No, we'll just keep this. If your square root of this thing on the inside, the argument on the inside was negative, right, then again, you'd have no solution because you can't take the square root of a negative number, at least in the realm that we work with. Okay. You now have a third equation you have to check. You have to check logarithmic equations. So if you get an answer, right, and a happens to be less than 0, then you have no solution. So you have to check. All right, you must check. I know right now with the multiple choice kind of things and the way the Connect works, you'll probably never really be held accountable for it, but someday you are going to be working on this, and if you don't get in the habit of checking when you have these three equations to solve, okay, these three types, you're going to come up with an answer. It's not going to mean anything. You're going to write it down and say, "There's your answer, Chief," and then you're going to be the one where it's like, how did they not catch that? Okay. So you don't want to be that person who messed up your yards to meters conversion, and then now stuff doesn't work. Okay. By the way, that's if you ever are working on an engineering thing, it looks bad on your whole team. So somebody else's job was to do it, but your team didn't catch it. Yeah, you're on the hook for that one too. Okay. So I used to work at an engineering firm, and every day I have one guy come in and ask me, like, "How many nanometers are in a meter again?" And we go through the conversion. Eventually, I just write it down on my board. But 10 to the 9th nanometers equals 1 meter. We just do it every day. Like, I don't care. Ask me every day, whatever. It's more important that we got the right answer and that we're doing it correct than it is to, feed my ego with telling you can't, you don't know what you're doing. That doesn't matter. You're a good programmer. Can't remember the unit conversion. No big deal. I'm the math guy on the team. Make sure it's right. So if somebody does something like this and you don't catch it, you're on the hook too. So let's check it. So it looks like it's not going to work, right? But we have to go back to the original equation. Right? My original equation was log base 4 of, what was this, 3w plus 11? Okay, that is equal to log base 4 of 3 minus w. If I plug in, right, 3 times negative 2 plus 11, that's still a positive number, right? That's log base 4 of 5. And if I plug it in over here, right, that's 3 minus a negative 2, I get log base 4 of 5. So those 5s are what you're looking for. Are these positive? Yes. So we're okay. So even though it looks like that wasn't going to work, I'm like, yeah, it does, because when we put it back into the equation, we get positive numbers. Okay. Now, I always tell my students, like, it takes longer to check it a lot of times than it does for you to eyeball it and just kind of look at it and say, by inspection, I'm good. So on paper, I would always tell my students, like, you don't have to go through all of this. You could just write down, I checked, and I'll generally believe you unless it's not true, and then I'll know you lied to me and you'll get it wrong anyway. I should do like my parents did. If you lied, you should get points more off. I don't really do that. It's already bad enough. But if you check, right, go through, because I'll tell you, look, I know you lied. If you didn't check, I know you didn't. I know you didn't. Okay. But I don't have a problem with writing. I checked, because a lot of these problems, you can just look at it and know. Even this one, it's like, I'm going to plug a negative number in here. Oh, that'll be okay. Oh yeah, 3 times 2 is smaller than 11. I'm okay. So it wouldn't have mattered, right? You didn't have to show me the arithmetic. I believe you. All right. So let's see where we are here. We are 12:42. I think I'm going to call it a day for this one, and we'll do some more. We got some good groundwork going here, so I think I'm going to stop here. So I'm going to go ahead and hit the stop recording here. So everybody have a good day.
Hey, mister.
Oh yeah, sure.
I had a question. It's not about this section.
Let me go ahead and stop recording, and then we'll go ahead and handle that.